Alright, welcome back. Today we're going to continue and talk about polynomials, and we're going to start off talking about what's called standard form. Standard form is a way of listing a polynomial so that it goes from a highest exponent to smallest exponent as you are reading the polynomial. Since addition and subtraction are sort of I believe the word I want to use is commutative, where order doesn't necessarily matter. For instance, 3 plus 5 is the same thing as 5 plus 3. 2 minus 7 is the same thing as negative 7 plus 2. We could switch the orders around. We could do this with polynomials as well. For instance, 3x minus 5 plus x squared is the same thing as x squared plus 3x minus 5. The order doesn't necessarily change the polynomial, but for us, it's going to change what we're looking at first. And the variables that have the largest exponent will have the most influence on the way a polynomial looks. Because as I start plugging numbers in there, those larger exponents are going to cause those numbers that I'm plugging in to change more rapidly. So for looking at polynomials, it's going to be wise for us to see the larger exponents first. And so when I have a polynomial, for instance, 7x plus 4x squared minus 8x cubed plus 5 minus 3x to the 8th, the way this is currently listed, it's hard to find the largest exponent first, which will cause the greatest change in the way the graph looks. I want to order it so that I can see the largest exponent first. And so that largest exponent is this x to the 8th. So I want to write that first, negative 3x to the 8th. And then I continue looking for the next largest exponent, which in this case would be negative 8x cubed. Then would come that positive 4x squared, then the 7x, then 5. So we want to order things so that the largest exponent comes first, and then the next largest, and it slowly decreases as we read the polynomial. The exponents slowly decrease as we read the variable. I hope this makes sense. I feel like my wording's a little unclear. Now, once we have something listed in standard form, that's where the exponents go from largest to smallest as we read it, we can talk about what's called the degree of a polynomial. Degree, just how you think it would be spelled, is the largest exponent on a variable in a polynomial. So up here, this polynomial that I just listed would be a degree 8 polynomial, because this 8 is the largest exponent on the variable. If I look at something like 3x squared minus 7x plus 4, this would be a degree 2 polynomial. Degree 2, because of this 2 in the exponent. So we're always looking for the largest exponent, and that tells us the degree of the polynomial. Later on, the degree of a polynomial is going to tell us more information, so it's going to be wise for us to understand 1, what the degree is, 2, how to find it, and 3, I'm hoping you can understand right now that when the polynomial is listed in standard form, that degree is going to be the first variable you come to. The next thing we're going to talk about today are what are called coefficients. And coefficients are the numbers in front of the variables. Numbers in front of variables. So if I look at the polynomial 7x squared, 7x squared minus, actually, you know what, let's make it bigger so we get more of an idea. Let's go 7x to the 6th minus 8x to the 5th plus 4x cubed minus 9x squared minus 12x plus 14. Every number that is in front of a variable is a coefficient. So 7 is a coefficient, -8, 4, -9, -12 are all coefficients. Now, this 14 back here, this 14, some view it as a coefficient, some do not view it as a coefficient. It all depends on who you're talking up to. I think if you're talking to somebody that doesn't view 14 as a coefficient because it's not in front of a variable, won't be mad at you for calling it a coefficient, because some view it as the coefficient of the x to the 0 term. Of course, any number to 0 is 1, so x to the 0 is 1, and that 14x to the 0 is the same thing as regular 14. So it's kind of up for a debate. I necessarily don't think of it as a coefficient. I think of it as that constant term. But I can see people calling it coefficient too. So your coefficients in this problem are 7, -8, 4, -9, and -12, and 14, depending on who you're talking to. The last thing that we need to talk about today is what's called the leading coefficient. Leading coefficient. And now the leading coefficient is the number, the coefficient of the variable that has the highest degree. I'm going to try and write that more clearly. So the coefficient of the term with the largest degree. Well, not, I shouldn't say degree, because that would be the degree, largest exponents. Exponents is a better way to write it. So in this problem that we just looked at, or the polynomial we just looked at, with all its coefficients, this 7 is going to be the leading coefficient. Our degree is 6, so that is the largest exponent, and the coefficient of that term is that 7. So 7 is the leading coefficient. We're going to look at one more problem, say -2x to the 9th minus 4x to the 7th plus 8x to the 6th minus 4x to the 5th plus 3x to the 4th plus x squared minus 7x plus 3. Holy smokes, that's a long polynomial. Now the degree, it is a degree 9 polynomial. Degree 9. Because the largest exponent is 9. And the leading coefficient is -2. I guess I'll write this out. Leading coefficient is -2. So that's all we got to look for. And now hopefully you could see why standard form is a good thing, because if I was to jumble this polynomial all up and bury -2x to the 9th somewhere in the middle, you would have to search all the exponents for the largest one, and then also find the number in front of that to come up with the degree and the leading coefficient. Again, these two things are going to tell us more about the way the graph of this polynomial looks than anything else. So it's going to be a good thing to keep in mind. And that is why we're covering it today. If you've got any questions, please leave them in the comment section below, and I will see you for the next video.